Today we're going to look at section 6.5, which is called Conditions of Special Parallelograms. Kind of works like the other day when we did conditions of just regular parallelograms. It's basically taking yesterday's lesson and turning it around. And so all we're going to do is look at a figure, look at the information they give us about the figure, and decide, is it a rectangle? Is it a rhombus? Is it a square? Does it meet the qualifications? And then you're going to say, yes, it meets the qualifications, or no, it doesn't meet the qualifications, and maybe you need just this one more thing in order for it to meet the qualification. Okay, so let's talk about the rectangle first. On the rectangle, there are two conditions that need to be met beyond just the fact that it is a rectangle in the first place, or that it's a parallelogram in the first place. So in order for a figure to be a rectangle, it means at least one right angle. So if you have a figure, opposite sides are parallel, making it a parallelogram, you've got to have either a box drawn, or they're going to tell you it's a right angle, or they're going to tell you it's how many degrees? 90. So right angles are 90 degrees, not 180. Okay? All right, the second condition that's going to need to be, could be met is that the diagonals are congruent. So if they give you a figure, and we'll call this, we need the vertices labeled A, B, C, D. Opposite sides are parallel, making it a parallelogram. And then you've got diagonals drawn in, connecting the opposite vertices. So either they're going to be marked with the same measurement. Say one is 25 centimeters and the other one's 25 centimeters. Or they'll have tick marks on everything showing that they're congruent. Or they'll have a statement such as AC is congruent to BD. Okay? If it has that condition met, then you say, yes, it's a rectangle. Okay? Those are the two conditions for rectangles. Now let's look at the conditions for the rhombus. Okay, so first off, the rhombus needs to be a parallelogram, needs to have opposite sides parallel, and then one of the following conditions. First one is one pair of consecutive sides must be congruent. One pair. If you have a pair of shoes, how many shoes do you actually have? Two. Okay, so we're going to draw a rhombus, and rhombus is the one I'm not the best at drawing at. Looks a little something like this. Opposite sides are parallel. We need the vertices labeled. We'll call this one E, F, G, H. And we need one pair of consecutive sides. Doesn't matter which one you start with. And it doesn't matter if the next side is clockwise or counterclockwise. So let's start with EF and say that it's congruent to the one up top, FG. Consecutive means right after each other. So EF, then FG must be congruent. If you can get one pair of consecutive sides, you say, yes, it is a rhombus. Condition number 2 on a rhombus is that diagonals are upside down capital T. What does the upside down capital T symbol mean? Perpendicular. Good. Okay, so we're going to draw another rhombus. Just looks like a parallelogram. Okay, opposite sides parallel. And then obviously on this one, we have to draw in diagonals. So we go inside the rhombus or parallelogram, draw some diagonals. If inside you have this little box indicating that it's perpendicular or a right angle or 90 degrees, any information that you're given of one of those three things, then you say, yes, that figure is a rhombus. Okay. On a rhombus, there's one more. Third condition that will prove that your parallelogram is a rhombus, and that is that one diagonal will bisect the opposite angles. So we draw another rhombus. Opposite sides parallel. And this time we only have to draw in one diagonal, but when you see it drawn, you'll probably see two because they're going to try and mix you up with these two conditions, right? They're similar. This one's that they're perpendicular. This one is that it's going to be bisecting an angle. So I'm just going to draw in one diagonal, and what's going to happen is it's going to bisect these angles right here, bisect these angles right here. Okay. If it happens to do both, great. But in order to meet the condition, you just need it to bisect the opposite angles. Okay? These are the three conditions for a rhombus. If it meets any of these three conditions, you say, yes, it is a rhombus. Any of these two conditions, you say, yes, it's a rectangle. So for a square, remember yesterday when we did the square had what properties? All of the properties of the rectangle and all of the properties of a rhombus. So in order for a parallelogram to be a square, it needs one of the conditions met from the rectangle, and one condition from the rhombus. If it has one from each, then we say, yes, it is a square. Bless you. I'm going to move this up. You'll see it in just a second. My papers, it's so damp, it's all sticking together. There it is. Okay, so let's look at an example. Example number 1. We're going to be given some information, and we're going to need to see if it meets any of the conditions in order to be a rectangle, a rhombus, or a square. Okay, so here's our given information, is that EF is going to be congruent to FG, and EG is going to be perpendicular to FH. Okay, so let's draw something, a parallelogram, and we'll label the vertices E, F, G, H. And here's what we want to prove. We want to prove that EFGH, in this case, is a rhombus. Right? So there's a couple ways to prove the rhombus, right? There's 3 different ways. And the 3 different ways, First way could be that one pair of consecutive sides are congruent. The second way could be that the diagonals are perpendicular. And the third way is going to be that one diagonal is going to bisect the opposite angles. So how do we know which one it's going to be? Well, let's start by taking this given information and labeling it right on our diagram. And then it might be kind of obvious, right? So if the given information is that EF is congruent to FG, we're going to go over to EF and FG and put tick marks. Okay, not carrots, but tick marks. And then the other piece of information is that EG is perpendicular to FH. So here's EG. Oh, let's connect them. They're giving us a diagonal. Is going to be perpendicular to FH. So I'm going to put the little box in there because they're perpendicular. So I'm going to indicate to myself, okay, there's a right angle in there. It's 90 degrees. So we've actually done two things here, right? This EF congruent to FG has one pair of consecutive sides congruent, and it has the diagonals perpendicular. Okay, but this one's kind of a trick question. Why? Because it doesn't tell us anywhere that it's parallel, that the opposite sides are parallel. Just didn't give us that information at all. And so it looks like it's going to be a rhombus, but we actually have to say no on this one because we don't even know, question mark, question mark, question mark, that it's even a parallelogram. All right, let's try another one that's not so tricky. Example number 2 is going to be a little more straightforward. So here's our given information. Given is that EB is going to be congruent to BG. FB is going to be congruent to BH. EG is going to be congruent to FH. And triangle EBF is going to be congruent to triangle EBH. That's a lot of information. That's good, right? The more information they give us, the more likely we're going to be able to prove what they ask us to prove. So they're going to want us to prove that EFGH is a square. All right, so let's draw EFGH. And I'm going to draw something that sort of looks like a square, but you could really just draw any kind of parallelogram. But because they want us to prove that it's a square, might as well draw a square and see if it works out for us. So EFGH. And then we're going to take all this information right here and we're going to label it right on our figure. Okay, so the first one is EB equals BG. So I'm not seeing a B. What do you think B is? Middle point. So I'm going to have to draw in some diagonals, connect them in the middle, and give it a B. Okay, so this says that EB is congruent to BG. So I'm going to put a tick mark here and a tick mark here. That means that diagonal was bisected. And we kind of need that to prove that it's even just a parallelogram in the first place, right? Because parallelograms have diagonals that bisect each other. Okay? It also tells us that EB is congruent to BH. So here's EB, here's BH. I'm just going to put another tick mark.